This is the training video for understanding the programming languages defined in IEC 61131-3 standards. There are 5 different programming languages that are standard throughout many PLC manufacturers. The graphical languages, which include ladder diagram, function block diagram, and sequential function charts, and textual languages, which are instruction list and structured text. Many of the PLC manufacturers allow you to interchange which language that can be used within any program. You can mix and match different language sections to accommodate the actual program or what you're trying to accomplish. There are several advantages and disadvantages for each different language. We'll take a look at some of these. For the ladder diagram, where an example is shown there on the right, historically the most commonly used programming language, mostly due to the fact that it's similar to electrical wiring diagrams, and it's ideally suited for discrete and interlocking logic. However, the disadvantages include the fact that it's difficult to implement sequential logic, and it's difficult to portray parallel branches, and there's many times timing issues involved as a ladder diagram runs from top to bottom. Then there's function block diagram. This one is more of a common language that we're seeing in the industry nowadays. It's well suited for overall process control schemes, and it mimics process flow diagrams. It allows you to see the flow of the diagram similar to a flow chart or a SAMA diagram, and it's somewhat intuitive based on the block names. You can tell what an AND block does, an OR block does. If you create derived function blocks, you can name the block according to what its exact function is. The disadvantage to the function block diagram is similar to the ladder logic or ladder diagram, where it's difficult to implement sequential logic or batch control. Then there's sequential function charts, which is shown on there on the right. This is well suited for sequential logic and batch control, similar to something that is repetitive, like a filter backwash. It closely mimics a flow chart, so if there's a step-by-step action and there's parallel branches that it require a decision, whether it's yes, it takes this path, or no, it takes this path based on a tag, the sequential function chart is most beneficial for those types of applications. The disadvantage is continuous monitoring of data is not easily implemented, so seeing the actual values of individual points within the sequential function chart is difficult to monitor. Then the textual languages, which are rarely used, and one of those being instruction list, which is hardly ever used. It's based on a stack manipulation. It is very efficient, and it's optimized code, so if you have a lack of memory, it's ideal for smaller applications because of the archaic nature of the instruction list that is typically not used anymore. It's like a machine language. The disadvantages are it's not well suited for larger applications, and it's very difficult to troubleshoot. It does not support structured programming, and it's not easily interpreted for those that are unfamiliar with stacks. Then there's structured text, which can be used, and it can be intermingled within derived function blocks or programming sections as discussed before. It supports high-level commands, supports structured programming, and is well suited for batch control complex algorithms. For those that are very familiar with structured text, you can use the if and if statements, looping statements, defined variables, for loops, etc., that are typical in structured text languages. The disadvantages are that users typically require more formalized training to understand the programming language or understand programming languages in general, and there's a higher potential for infinite loops in case you don't close a loop, and it's very difficult to troubleshoot as you're stepping through the program. This is going to conclude the training for the different programming languages available under the IEC 61131-3 standards.